Hello, my good guys out there. Welcome to Learn with Dr. D.I. June on chemistry lectures. If you see on the board there, the main theme is chemical combination. But under this chemical combination, there are a lot of subtopics to treat. So for now, we talk about electronic configuration under the main topic, chemical combination. Now, ordinarily, when you say electronic configuration, the word electronic is from the word electron. Configuration, arrangement. So when you say electronic configuration, arrangement of electrons. And electrons are parts of atoms of elements. So when you say configuration of electron, it means how electrons are arranged on the shells of atoms of electron, of atoms of elements. Now, let us go by what I have in my note. Then we shall be discussing and then explaining. Now, elements in the periodic table are arranged in horizontal and vertical columns. Those of you out there who knows about the periodic table, there are columns, vertical and horizontal. So, each horizontal row is called a period. Horizontal, this way like this, is called a period. While the vertical columns running from north to the south are called groups in the periodic table. I know this is not too new to you. Now, these elements with similar chemical and physical properties. There are some elements that have physical and chemical properties that are very, very similar. And those ones, also with similar electronic configuration, they appear in the same vertical group. In the same vertical group, you see some particular elements. It could be non-metals or could be metals. They have similar chemical properties, also similar chemical properties. So they may have similar electronic configurations. Now, the atoms of elements in the same group have the same number of electrons in the atomos shell. If you see the structure of the periodic table, the vertical groups, the element that may fall under that vertical group, they will have the same number of electrons on the atomos shell of the electrons. Now, the periods correspond to the filling of an electron cells. The periods. We have period 1, period 2, period 3 to period 7. So under period 1, it means that every element on that group has only one electron in the atomos shell. That's what it means. That is, the number of electrons remain the same on that period 1. Every element atomos cell receives just one electron in the atomos cell. But the electrons on the atomos cell increase by 1. But on the contrary, the number of cells increase on going down a group. If you are going down the group of the periodic table, the number of electrons will begin to what? Increase. All right. But the number of electrons in the atomos shell remains the same. As the cells are increasing as you go down, but the number of electrons on the atomos shell remains the same. You will see that when we go to a configuration of electrons practical on the board. Now, apart from the first period, each complete period begins with an alkali metal. When you say alkali metals, group 1, group 2 mainly, and they are very reactive metals. And it now ends with what? A noble gas. When I say noble gas, these gases are in group 0 and they don't take part in chemical reactions. So they are called inactive colorless gases. Now, the elements before the noble gas in each of the complete periods is a halogen. The halogen are very reactive elements. We call them halogen because they quickly react with mostly metals to form salt. So, like carbon, bromine, chlorine, fluorine, they are halogens. All right, now after the first period, starting within an alkali metal, then the property will change from metal and from element to element. That is to say that the metallic property of the element will now begin to fade and gradually replaced by non-metallic property. Now, in group 1, you are going down to group 2, to group 3, group 4, to group 7, group 0. Now, as we are going from group 1, the metallic property of the element will begin to gradually fade. Group 1, 2, 3. Basically, these are elements and they are reactive. The moment you enter group 4, the metallic property of the element begins to fade and the element now becomes what? A non-metallic property group that way. Now, after a highly reactive non-metal is reached, this complete period ends with what? A noble gas. When a noble gas is about to be reached, just before it, the element just before it is an halogen. That's group 7. The moment you go beyond that, group 0, and those elements are the noble gases, which we call them the inactive elements. The periodic table classifies atoms into chemical behavior. And also what? Chemical behavior is derived or determined by what? Electronic configuration. The configuration of the elements will determine the chemical properties of the said element in question. Now, there is something we ought to know about configuration. Now, the periodic table also may be said to classify atoms by electronic configuration. So the maximum number of electrons in a given shell can be obtained by using a formula. There is a formula we use in determining how many electrons will be in each of the cells as you proceed from the nucleus upwards. Now, if you look at it there, the first shell, the formula there is 2n squared. That's what you have here, 2n squared. While this n stands for the particular cell in question, the 2 here is a constant. It's a constant. We'll get there as we begin to calculate. Now, the first shell, look at this structure here. This is cell number, which is the n, maximum number of electrons, 2 times n squared. That is the formula. Now, the very first shell, as you graduate from the nucleus of the atom, it is called the K shell. Next to the K shell is the L cell. Next to the L cell is the M cell, N cell, O cell, in that order. Now, the very first cell that you will see after you graduate from the nucleus outside is numbered as 1. The second is 2. The third is 3. The fourth is 4. And the fifth is 6. And is graduated like that. Now, to know how many electrons that will occupy the first shell, it is a known fact that the first shell can occupy or can accommodate only 2 electrons maximally. Nothing more than that, only 2 electrons maximally. So the formula is now 2n squared. The n stands for number of shell. So now the n here is now 1. So 2 times 1. 1 square means 1. 1 times 1 is 1. 1 times 2 is 2. So 2 electrons will enter the first shell. When you go to the second cell, which is the L cell, the n represents now 2. So 2 times 2 squared. Mathematically, you square it one first. 2 times 2 is 4. 4 times 2 will give you 8 electrons. Now the third cell is M, and the n stands for now 3. 2 times 3 squared. 3 squared is 9. 9 times 2, 18. So in that order, you can work for the n and also the last one, O. So this that now under normal circumstances, you will see that the O shell, which is the fifth cell from the nucleus, going outside the nucleus, will what? Have 50 electrons. That's how it's supposed to be. Now, let us also consider the first 20 elements. That is from hydrogen to calcium. Let us consider the first 20 elements. And as I used to say, if you are a chemistry student, to me, it is compulsory that you must know the elements from hydrogen to calcium. You must know the atomic number, you must know the atomic mass of each of the elements, you must know their chemical symbols. It is very, very important because the first 20 is very, very important. Now, the first element, hydrogen, has only one electron, and that one electron occupies the K shell. Now, the second element in the periodic table is helium, which of course you know. It has 2 electrons. So, the 2 electrons will occupy the first shell because in hydrogen, the first shell is not even filled, it's half filled because the maximum electron is 2. Hydrogen has only 1 electron. So the shell of hydrogen in this case is not filled, it's half filled. When we go to configuration in a higher level, talk about the SPDF, then you will see whether it's half filled or completely filled. We talk about metals in transition. You're not going there yet. Then the third shell, the third element is lithium. Lithium has 2 electrons in the first cell and 1 electron in the K cell because there are 3 electrons. The first 2 electrons go to the first cell, which is complete. Then the last electron go to the second shell. All right. Now, the configurations of elements are derived or are obtained by successfully adding electrons to the outer lowest available unfilled shell. Now, assuming this element has 25 electrons, you will give 2 electrons to the first shell. If you take 2 away from 25, you have 23. It means that the first shell is already filled, so you can't add any other one there. You will now consider the second cell, and the second cell will take 8 electrons maximum. So out of the 23 electrons that are left, you will now use 8 to fill the second shell. 8 plus 2, 10. If you take away 10 from the 25, you still have 15. Now the third cell is 18. So, but now the 15 you have is now less than the 18 that's supposed to go to the third cell. So there is a provision that since what you have is less than the 18 and they are less than also 32, you give this third cell 8. So you can give it 8, 8. That's why if you see some of the, if you go to calcium, the combination is 2, 8, 8, 2. It means that because the number of electrons are less than 32, and they are also less than the 18 that's supposed to be there, so you give it 8, 8. By then we draw the structure, we'll come to that. Now, the surrounding electrons on the outer shell are called the valence electrons. Now that means the outermost shell of the element is described as what? Valence shell. Valence. The word valence. Valence shell. So it means that that is the outermost shell. Let me see here. Outermost. Outermost shell is also called what? The valence shell. So the electrons that are found on the outermost shell are also called valence electrons. So when you say valence electron, it is telling you that the electrons that are found in the outermost shell is what you are required to find out. So if it is 2, if it is 3, then you will begin to know. All right. Now, we said that the configuration of what elements are derived by what? Successfully adding electrons to the outermost shell. That is already known. Now, similarly, the similarity in the number of valence electrons account for what? Similarities in properties. Let me take it again there. The similarity in the number of valence electrons accounts for what? Similarities in properties. Do you see now? So if element A and element B and element C probably have one electron in the outermost shell, so their physical characteristics and also that of the chemical ones may look similar. That's what they're talking about here. So now, at this point, let me give you the structure of an atom. Then from there, we now know how the structures and the arrangement will look like. So, now this is the first shell, and this is the nucleus. The nucleus is made up of 2 particles, the protons and the neutrons. Then we have other cells surrounding it. Let's stop here. Now, this is the first shell from the nucleus. So this one is called the K cell. This is the next shell from the nucleus. KL, this is the L shell. Now, this is the third shell from the nucleus. After L, L is M, M shell. This is the fourth from the nucleus, MN shell. So if there's any other one here, it becomes what? The O, M and O. So that's it. Now here is the nucleus. The nucleus. Now let us demonstrate the structure as we said from that table. Now this first cell, this K cell, contains maximum of 2 electrons. The second cell, maximum of 8 electrons. Then the third shell, as I said before, if the electrons are less than 18, it means you will give this 8 electrons. Right. Now, assuming now that you have 2 electrons left here. Now, this configuration here will tell us, now let's see, configuration. This is 2. The first shell contains 2. The second shell contains 8. The third shell also contains 8. And the last one contains 2. Now you can now determine the element by adding these together. 2 plus 8 is 10. 10 plus 8 is 18. 18 plus 2 is 20. So the 20th element is what? Calcium. So from here, you know that calcium has 20 electrons. So 2 go to the first cell, 8 to the second cell, another 8 to the third cell, and then 2 to the fourth cell. So these electrons we are seeing there is what we call the valence electrons. These two called the valence electron, because this is what we call the outermost cell. So the element, so the electrons occupying this outermost shell are what we call the valence electrons. So the shell is called the outermost shell. All right. Note that the third cell, which is the M cell, can also contain what? A minimum of 8 electrons, which I said before, as the case may be for some of the elements. Now, let us consider some structures of elements. Using this pattern now, this is a general one, but let us use some specific ones if you can go along with me. So let's talk about sodium, magnesium, potassium, calcium, and nitrogen. Of course, from this we already known this is what? Calcium. Okay, let's go to some specific ones. Now, if you want to know or to write the structure of a given element, there are certain things you ought to know. You see, before you can successfully construct the structure of an atom, you must know the following. 1, name and symbol of the element in question. The name and the chemical symbol of the element in question that you want to construct the structure. 2, you must know the atomic number of the said element. 3, you must also know the number of protons, electrons, and the neutrons of the element in question. Then 4, you must be able to determine the atomic mass of the element that you want to construct the structure. So, you must note the following. Put it down here. Let me give it to you. Note, atomic number is also equal to number of protons. Then number of protons is equal to number of electrons. Then number of neutrons is equal to atomic mass minus number of protons. Can you see now? This is an important information. As long as you are determining to construct the structure of an atom, after knowing the parameters I give to you, you must be able to know the atomic number of the said element as it appears in the periodic table anyway, serially. Then that number of the atomic number you are seeing is equal to the number of what? Protons. It's a basic fact. Then if you have determined the number of protons, it means the protons are also equal to the number of electrons. And that's why every element in the ground state is electrically neutral, because electrons are negatively charged particles, while protons are positively charged particles. Now, mathematically, for example, say minus 5 plus 5 means 0. That's what it means. Plus 5 minus 5 is 0. So negative, positive, if they are equal, is neutral, 0. Then, to determine the number of neutrons, because it is the neutrons and protons that constitute the atomic mass of the element. So to determine the neutrons, you subtract the number of protons from the atomic mass. So without knowing the atomic mass, you will be able to derive what? The neutrons. And that's why the 4 parameters I give to you are that you must know the name and symbol of the element. 2, the atomic number of the said element. 3, the number of protons, electrons, and neutrons. And 4, the atomic mass. So when you know this parameter, it is contained in this place. Then when you have gotten this information, you can now successfully what? Construct the structure of any given atom. Now let's give an example of sodium atom. Sodium atom. Sodium atom. Now from here, let's go. Symbol of element. Symbol of element. Of course, you know Na. Then atomic number. Atomic number. 11. Now, since you have known, okay, atomic number is equal to protons. So yeah, number of protons is equal to 11. Then here said number of protons is equal to electrons. So number of electrons is equal to 11. Now number of neutrons. So before determining this, you must know atomic mass. So atomic mass is equal to what? Atomic mass is 23. Of course, you know that one. Now from this, subtracting number of protons from atomic mass give us the neutron. So number of neutrons will be equal to 23 minus 11, and that gives us 12. Now when you have done this, you are now ready to go to construct the structure. Now the center, of course, the nucleus. The first shell, you have 11 electrons. So 2 maximum will go here. Now if you take 2 out of 11 electrons, you have 9 electrons. So the second cell will contain what? 8 maximum. So 8. So 2, 2, 2, 2. Now this 8 plus 2, 10. Why? Because you have maximum of 11. So if you take away 10 from 11, you have 1 left. So the third shell will have only 1 electron. So sodium is now 2, 8, 1. This is the configuration. And because this one is the last electron, which is called the valence electron, it means that sodium is occurring in what? In group 1. Because if you understand my note I was giving you, the last electron occupying the last shell determines what in the particular group that element is falling into. So all the elements in group 1 means they have 1 electron in the atmosphere shell. All elements in group 2 means they have 2 electrons in the atmosphere shell. All elements in group 3 means they have 3 electrons in the atmosphere shell. The same thing with group 4, 5, 6, 7. Like chlorine, the halogens like bromine, astatine, they are all having 7 electrons in the atmosphere shell. You see that? So now in group 0, it means that the atmosphere shell electrons are 8. And once it is 8, that is the maximum it can contain. So it cannot give, it cannot receive. So they become inactive. We call them the inert gases because they are not reactive. So this is an example of how you can construct the atomic structure of elements. Now this is for sodium. You can do so for calcium, you can do so for potassium, but the most important that these 4 parameters must be known with this information. Once you are done with this, it means you can construct the atomic structure of elements. So, those of you who are there, use this to construct that of potassium. Potassium is 19 in the atomic number. So, the atomic mass is what? 38. So, go and work on it. See you next time. Thank you very much.